Welcome back, students. Lesson 15, Part B. In this lesson, the official steps to do a confidence interval for one proportion. In the previous video, Kim Shepard did a fantastic job going through an example. But we did take a few shortcuts, a few liberties, just to get the ideas down. So definitely we want to understand the ideas in the previous video. Now we have to do the official methodology. So that's what this one's all about. Official steps. Check the conditions. I know at times it might be a little tedious, but listen, these statistical methods don't work unless all the conditions are met. These should seem awfully familiar. They're basically the same thing as chapter or lesson 14 when we modeled the sample proportion. So we're working with proportions, variables, categorical. Always, in the next three lessons, you've got to think of the variable that you're working with. It has to be categorical. Ideally, the sample is random, but true random samples are very hard to collect in practice, so at least unbiased, right? At least unbiased. Sample size needs to be less than 10% of the population size. And you know the numbers here, right? We have at least 10 successes and 10 failures in the collected data. So a little bit of a slight nuance here in D. When we cooked up the theoretical model in lesson 14, we wanted the expected number of successes to be 10. And we could do an n times p greater than 10 and n times 1 minus p greater than 10. To check D here, it's the same thing, but we're working with the data, so it's p hat. And to check D, you would do an n times p hat greater than or equal to 10, and an n times 1 minus p hat greater than or equal to 10. Now, you'd never make a computational mistake, because this is the numbers that you'd have, but just make sure we get the right symbols and maybe notice the difference here. Okay, so those should be familiar. All right. What are the next steps? You collect your data. We're working with a sample of data. You'll take the data, say you're doing gun ownership, you've got a certain number of homes that have guns over the total number. You just convert your data to p hat, sample proportion. That's an easy calculation. Number of successes over the sample size. Part 3, using the standard normal model, determine the value of z. So when Kim Shepard did it, we sort of fell back on the empirical rule. I have to tell you, all semester we've been slightly lying to you, where we've always said that 2 standard deviations is 95%. It's a little bit of rounding in there just to make the numbers easier for everybody to remember. As we proceed, that number 2 might be something different, and I'm going to teach you in this video exactly how to get the z number. Okay, details are on the next page. The number z is called a critical value, and it's based exclusively on the confidence level. So what does that mean? If you're told to make a 95% confidence interval, the z will be a certain number of standard errors you'll jump out. Other confidence levels might be like a 99% confidence interval. That will change z. So you read the problem, you figure out the confidence level, and then you figure out what z needs to be. Step 4, calculate it using the following formula. Pretty easy, it's p hat plus or minus. So here's our best guess, remember, it's p hat plus or minus. There's that z number that we need to be able to find, and then times standard error, so it's z times big square root there's your standard errors, the p hat, 1 minus p hat all over n, whole thing square rooted. Okay. This side here, maybe we'll, this is your best guess. You might call this like a point estimate. This is like a point estimate here. And then plus or minus. This whole right-hand side has a word for it, well, 3 words, margin of error. And I'm sure you've heard of margin of errors, especially around like voting time, if you're watching elections on TV. This whole thing is called margin of error. When you calculate this by hand, you clean up this right side first, make that into one single number, and then do the adding and subtracting. Okay, so point estimate here, and then plus or minus that margin of error. All right. The z number comes from the standard normal model. Maybe we'll write just a little note here on the side. Put it in a box. That number z comes from standard normal model. Z should remind you of something you know about, z-scores. And z-scores deal with the standard normal model. And of course, if I asked you a question, you instantly know the answer. What's the mean of a standard normal model? Of course, it's 0. Standard deviation is 1, right? That's that one very important normal model. Okay, so we'll get that. And finally, step 5, interpret your interval with a sentence in context. Video A, all these steps were done. It's just that maybe we rounded to 2 based on the empirical rule. Not allowed to really do that anymore because it will make a difference. All right, so let's flip the slide. Let me take a look here in the notes. Finding the critical value z. What we'll do is we'll find these on StatCrunch. Once we find them on StatCrunch, write them down somewhere where you can find them because they're going to be the same z numbers for lots of problems. And I don't want to have to generate a normal model, go on to StatCrunch 100 times. Just the numbers that we get on the next page or so, put them somewhere you can find them or memorize them. You'll memorize them anyways, just inadvertently because you'll be using them so much. So we use StatCrunch normal model calculator. In practice, I think these are the two most common, 95 and 99%. Okay, less common, but still used, 90 and 98 percenters. And the steps that we do, if you're ever asked, once in a while we'll ask you for a crazy one, like make a 93% confidence interval. It doesn't happen all that often. But you'll know how to get that z value, finding the critical value z for the confidence interval formula. Okay, so if I flip the slide, let me just tell you what we're going to do. We're going to go to StatCrunch, get the critical z value for a 95% interval. We'll do 99, 90, and 98. They come quick. Remember what we're going for. The formula is p hat plus or minus z. Right, p hat plus or minus z times this, that's the number that we need to find. All right, so load up StatCrunch, I'll get these lights down. Can't remember if we do all of them off or just the front. Yeah, we'll go with this. All right, let me escape out of here. Now, let's see here. We'll go to StatCrunch, we'll log on. You can really open up any data set, but a blank one will be nice and clean here. We're not working with data. For this problem, we're going back to that normal model calculator. We've used this normal model calculator before. If we were shading normal models up or down or in between, or maybe we know the area and we're looking for values on the horizontal axis. So fire up that normal model calculator. Looks like this. Let me just put it, maybe there's a good spot. I think I can make it a little bigger maybe. See how that works. And so here's the idea. If I want to do a 95% confidence interval, I need to find the two values where if I started at the center and jumped out those two values, left and right, that 95% would be in the middle. And all semester long we've been telling you that it's 2. Plus or minus 2 corresponds to 95%. Let me switch this to in between. Notice the mean is 0, the standard deviation is 1. I mean, this is a z-curve. And in fact, I'll just label this as, this is how we could say for shorthand. I mean, that's a z-curve there. And, oh, is it going to let me do it? I should have practiced before if I put 95. Uh-oh. All right, we've got to do it the long way. I'll go back to standard. Sorry about that. Let's see. I'm going to draw here on this graph. Oh, right there, because I sort of know the answer. And right here. Just a smidge inside the 2's would be 95%. Okay. How much is left over? 100% total. I've used up 95%, so it's not shaded properly now. It's going to be, I want to get to the answers first. 5%, if I cut it in half, is 2.5% in each tail. The in-betweener really doesn't let me put area in the center and give me the two values. I know why, but we'll... Oh. Some error messages here with our campus technology. We'll just close that out. 2.5% down in this tail here, students. 2.5% in this upper tail here. And in the confidence interval formula, what we're saying is jump out to the left, 2.5% left over here, and jump out to the right. Now, all semester long we've been telling you it's 2, but what's the true answer? What I'll put here is probability down in the bottom, probability x is less than, and I'll put 0.025 and I'll hit compute. So what I want to do is put 2.5% of the area in the left tail, 0.025, and I'm solving for that number on the x-axis, the horizontal axis. It's really 1.96 negative. Okay, so this spot here, we've rounded to 2 all semester, but no longer can we round to 2. Don't want to change my color scheme here. Negative 1.96 is the number that puts 2.5% in the left tail. Without even thinking, can you tell me the number up on the upper tail? Right? It's positive 1.96. You can check that at the bottom. All right, so what did I do? I changed the probability x is greater than, and I put 0.025 for the upper tail, and I got a positive 1.96 up there. And so, let me see. What did we learn for all this? If I want to do a 95% confidence interval, I'll abbreviate confidence interval CI often. The z number equals, whoops, the z number equals 1.96. In video A, Kim Shepard used the value of 2 because that empirical rule is just rounded. But we'll actually use 1.96. in the formula. If you think quickly, p hat plus or minus a z times that standard error, 1.96 would go in for the z. And you can see, where's the plus or minus coming from? Here's the minus down here on the left. Here's the plus up here on the right. And so you'll plug in 1.96 into the formula. So off to the side, I'm just going to keep a little list here of the confidence level. We don't need to get this on the screen the whole time, but maybe at the end. Confidence level, and then what? What's the z number that I would need? So in this video, we're going to do 90, 95, 98, and 99. And we're 1 done, and 95 we learned was 1.96. All right. Curiosity is just killing me. If I go to the in-betweener tool, and at the bottom I put probability that x is between negative 1.96 and positive 1.96. There's the picture I thought I could generate instantly, but it won't let me do in-betweeners with the tool. So if I wanted to find the shading, 95% rounded, I mean, you can see 95,000,421. That's the number, negative and positive 1.96. Okay? So, long discussion to get the first one. The next three will come quicker. The magic number, if you're asked to do a 95% confidence interval, the z is 1.96 from this point forward. All right. No slides to flip here. We'll clean it up. On the next page, looks like 99% comes next. So if you were told to do a 99% confidence interval, find the z number. If I wanted to be more confident to hit the target, let's say I'm estimating the true proportion of Cecil County gun ownership rates. I want to be 99% confident. Don't I need to jump out further in the tails to make my confidence interval wider? I do. So the 1.96 that we had for a 95% confidence interval is going to be a bigger number now, bigger than 1.96. All right, we've got to switch over to standard. If I'm going to put 99% in the middle, how much is left over, students, for the tails is 1% in the tails left. If I cut it in half, right? 1% is 0.01 as a decimal, and if I cut 0.01 in half, I'm getting an 0.05 in each tail. So be careful with, this is the trickiest one, at least with the decimals. 99% in the middle, 0.005 in each tail. All right, is that about 7, I think? Put the over-under at 12 here for the video. I'm in standard, or I will be. Let's see. We go back to standard. The mean is 0. Standard deviation is 1. In the left tail, let me put 0.005. I change to less than, and I'm going to compute. Way down here, that's the 0.005. Remember, we're sticking 99% in the middle from here and then up to here somewhere. That's the number that we need. It comes up here as a negative 2.5. Oh, usually this one's rounded to 2.576. It's quite a lot bigger than the 1.96 we just had. And so what we're saying is if I needed to be 99% confident, I guess we're jumping out about 2.5 standard errors. Which makes sense, right? If I jumped out 3 standard errors, I'd be 99.7% confident. And that's not a common one you'll ever see in practice. We already know what the answer is up here. It's going to be a plus 2.576. I'm afraid to pick any of these. Stick that down there, maybe. Change this to greater than. You know what the answer is going to be. If I go greater than, and I put 0.005 in the upper tail, 2.576 rounded. And so if you're asked to do a 99% confidence interval, the z number is a 2.576. Again, put the confidence level area in the center and find the 2 cut points that do the job. On my table over here, I don't know if it's on the screen or not, but we'll check it out at the end. Oh, I get a 2.576 for the 99%. All right, good job. There's C and D. We'll go to 90. So, let's see. Clean this up. And do you see how, students, this is a bit of work? Keep these numbers handy. You're going to need them again and again on problems. All right, let's see here. 90% confidence interval. would have 10% in the tails, cut in half, 5% in each tail. Let's see here. I'm going to do a less than, so let's see. Probability x is less than 0.05. Be careful with 0.05 versus 0.5. 5% is 0.05. I put 0.05 here. I put 0.05 here. Right? And I'm sticking 90% in the center of that normal model. We're asking ourselves, how many standard deviations, or standard errors, I should say, do I need to jump out to put 90% in the middle? This number should be smaller than 1.96, and it is. Typically, you'll see it listed as a 1.645. I already know it's symmetric, so up here would be a positive 1.645. And I just don't know to like throw my marker down and go running down the hall, but I'm just going to keep clicking this because we're so far invested in this video. Trust me, it's 1.645 on this, and so if you're asked to do a 90% confidence interval, that Z number is 1.645. Put that on my table there, and there's one more to go if I can keep my sanity. 98%. Let's see here. This is the least common one. If you're asked to do a 98% confidence interval, what are the Z numbers? 98% confidence interval, 2% total in the tails. Chop it in half, 1% in each tail. As a decimal, 1% in each tail, 0.01. So I need to make this a 0.01. All right, we've got the idea now, standard normal model. Oh, I'll do the upper tail this time. Probability x greater than, and let me put 0.01. So I looked here, I put 0.01 in the upper tail. Down here would be 0.01. And 98% confidence interval says we would stick 98% in the middle. This one is typically presented as 2.33. And that's the Z-score. I'm not sure why. Why don't they do 3 decimals here, or like a 2.326? You can do that, it's fine. I've seen 2.33 in a lot of textbooks. So we'll pop that on the table here. Squeeze this all in the light. And that's it. That's how you get those numbers. If I asked you to do a 93%er, stick 93% in the center, figure out that there was 7% left in the tails, chop it in half, 3.5%, and use the normal model tool to get that number on the x-axis down here. Okay? If we look at the table over to the side, you can see, and these are important numbers, so I don't know, write them on the cover of the book or something. The more confident we need to be, and we'll talk about that more in class in future videos. Like sometimes you want to be extra confident that you hit the target, whatever you're estimating. What you need to do is make your Z purposefully bigger. Like if I want to be 95% confident, I'll jump out 1.96 standard errors. But if I need to be more confident, say 99%, I'll jump out about 2.5, 2.576. We're purposefully making the interval wider. There's some drawbacks to that. If my interval is super wide, how useful is it, right? If somebody asked me to estimate the mean age of Cecil College students, and I said, well, I'm 99.99% confident it's between 15 and 45 years old, we're not really telling anybody anything, right? So you're balancing, like, how confident you need to be versus how wide of an interval can you live with to make some informed decisions. And it's just a balancing act. All right. we're going to do some troubleshooting on this computer here and try to figure out what's happening with these pop-up windows. Thanks for watching. Hope you got what you needed out of this video. I certainly understand if you didn't, but we will see you in class, and of course we'll be practicing this. So thanks for watching.